much for coming. I'm Natalia, and just a couple of things about me. So I'm a consultant at Erlang Solutions. I'm also a former academic, and so I've got research interest, and that research interest are distributed systems, all sorts of scaling. That's my passion. I'm also a chair of the Embedded System Group, and that is Erlang Ecosystem Foundation. So if you're not members yet, please join. In particular, if you're interested in robotics, in distributed robotics, embedded system, all those things, do join the Embedded System Group. And I'm also a steering committee chair for the Erlang workshop. So if you have ideas for publishing, you're interested in publishing, then do talk to me. There is lots of support for developers to publish at academic events, so do let me know. Right, so let's talk about observability. Observability is really, really needed, and why do we need it? We need it to understand our system. We need to understand what it is, how it works. We also need it to sort of plan, right? We need to understand where the limitations are, where we need to scale, where we have the bottlenecks, where the performance is not good enough. So we need to know all this information to make informed choices, how exactly we change, how exactly we improve our system. We also need to be in control. Right? So it's not that we are thrown errors at us, we quickly sort of type very frantically trying to solve it, and then sort of breathe and then get another one, right? So what we want time, we want space, we want to plan, we want to know what's happening, where it's happening, and then plan our work. We don't want to do that over the weekends and the evenings when we want to spend like doing our hobbies and spending time with our families, but something during the working hours so that we can distribute the work between the developers. And also to address the issues promptly, right? So if we know where the bottleneck is, we can design for it, we can make the plan, we can make the changes, rather than, blindly like debugging and looking for it and, making assumptions and then changing and making assumptions and not seeing the result of our work. And this all leads to preemptive support, right? So observability is very much about preemptive support. We don't react on things, we act in a good time. And what we say is that we observe things. We observe indicators, right, that our metrics provides. We observe trends, again, coming from metrics, and all sorts of alarms that are coming our way. Yes, so we don't react, we plan, we design. But then, why don't we use it, right? So it all sounds amazing, and we all should metrics in place, and they all should work, but we don't have them. And lots of story I hear is that we put metrics, our systems doesn't perform as good as it used to before. We just removed everything, right? They sound amazing, they sound really good, but when you put them, they don't actually work. And they take space. It's difficult to justify. So it's difficult to justify to managers. Why would we waste our time on something? It's difficult to justify ourselves, right? So we have deadlines. We need to do lots of things that needed to be done yesterday. Why would we invest our time into metrics or logs or alarms for that? We put them in, and they create mess, right? So the code becomes unreadable. It's really difficult to, work with them. And essentially, when the time comes, it's just such a mess, we don't use them anyway. So the thing is that observability needs to be designed, right? And if you just throw the metrics or logs or any observability at your code, so what you do, you throw rubbish at your code, or you sprinkle this rubbish in your code, right? Whatever you do. But why would you expect if you throw rubbish or sprinkle rubbish, then you would get something useful, right? So if you want something to work, you need to design that. And then we won't get this funny result. So when we think about observability, it's important to distinguish between them. We have logs, we have metrics, we have alarms. And if we have alarms, that's not enough, right? We need metrics, we need alarms on top of that. And the reason that these three aspects, they actually look at different times of our system. So when we look at logs, it's what happened already. And we're not supposed actually to look at our logs. Just think how your logs look. Just lots of text, and there's lots and lots of that text. Even if you look at it, they won't change much, right? Unless you get the same error all the time. That's all information you can get, or how many you get them, or how little. Metrics, it's what's happening at the moment. It doesn't mean that you can't look at the trends, right? It doesn't mean that you can't look at the past and see what has happened. But metrics very much about the present time of your system. And alarms, they're all about the future. They're about telling you what is going to happen, right? You just listen to alarm. That's where you need to look at it, where you need to take care. So it's all about different times of our system, and sort of today will be about how we design all those different aspects, and some sort of things that we need to look out that your observability is actually working for you. Oh, another way. So logging, when we have logging, we actually log two types of events, broadly speaking. We log failures, so something went wrong, and we also have audit logs. The audit logs is where everything was fine, but we need this information for some reason. So for example, this is very common and very familiar to fintech, right? Or anywhere where money is involved, right? So we want to demonstrate that, for example, request has been received, money has been issued, that's it, we dealt with it, right? So we have two of those types. Important thing don't to forget is that we shouldn't confuse logs with debugging. Logs is about what happened in your system, important events, errors, audits, all those things, right? Debugging, you've got a problem, you need to find that problem, and you remove that debug information from there. The reason we shouldn't confuse them, so the first one is when we talk about audit logs. Audit logs are on a happy path. And then you collect information. It will be overheads, right? We had a client at some point, and they said, we want to have zero overhead observability. It's not possible, you know? You interrupt your system, even for tiny bit, depending on your design, but you're still interrupting it. You're slowing it down. Depending on your design, you may slow it down just a tiny bit, or you can slow it a lot, but you're still slowing it down. So what we can strive for is minimum overhead, but not zero overhead, right? Another thing is that when we generate those logs, it's information, and somebody needs to go through that information. And especially when you've got a problem and you need to solve this problem, you need to find the reason for the bug, right? It's not a fun when you have like gigabytes of data, millions of lines to go through to find what's happening. So your logs need to be sufficiently short, contain all the information you need so that you can find it relatively fast. So let's have some of the rules that sort of were generated by my experience and experience by my colleagues at Erlang Solutions, what we need to keep in mind when we think about logs. And first thing is design your logs, right? Introduce them from the very beginning. And important thing again, don't throw, don't sprinkle, design them, right? Where do you want to have them? If you already have a mature system, and then you think, okay, I will design, I'll think about thousands of logs and I will put them in one go. Please don't do that, right? Put your logs gradually to the code that you're using. Make sure that you check your logs, right? Make sure that you start using them. Do you have sufficient information there? And another thing is to think about the tool that you're using, right? So your tool is going to go through your logs for optimization, cleanup, whatever. Do they have, by default, some kind of synchronization? So these events happen all at the same time. Is it happening on the node that is deployed in your system? Are they going to take, will this sort of synchronization thing on cleanup will take resources from your application? So in this case, it's better to take them out to another node, for example. So when this synchronization happens, when the cleanup happens, it happens at a different machine, not on the node that you're working on. Avoid mess. So document your logs. And by documenting, I'm not saying create some kind of Word document where you can do that. Do that in sort of inside of your code. Another sort of good tip is never having these observability tools inside of your applications, right? So create some kind of internal API where your code actually calls this API, and then your API calls the tools. The reason to use that is, for example, well, you will need to change the tool. You don't like it for some reason. There is a better tool out there. You don't have to go through all your code and replacing all those sort of logs, calls, and things like that. Sometimes you actually won't be allowed to do that, right? So if your code base is huge and you have a separate team who works on testing, they will actually tell you, well, thank you, but no thank you. We'll continue to work with what we have, because you can't just go through all the code and just change it. That's too much change. We're not authorizing it. And another thing is make sure that your logs have IDs. And those IDs are used only once. So when an event happens, you don't look for various places where this might have happened. You know exactly where the problem was. And also use your logs so you can revise them so that your logs don't contain too much information, right? Unnecessary information. Have a look at the logs that are before that. Do you pass the same information over and over again? Sometimes it's useful, right? Sometimes the state may change or something, but do you really need all the state, right? Do you really need to send that message again, especially if that's binary or XML or whatever that is? That's lots of space. You will need to go through it, so think about that. I already started talking, so how to structure your logs. So one thing is for logs to have ID. Another important information is values, right? So we talked about what exactly you want to pass there, some useful information that will help you to understand your logs. Impact, right? So write information, if this happens, what's the impact, right? Extend it, especially, and then think about the solution, right? How would you solve this problem? Because very often what happens is that we work on something, we know an error is going to happen, but we don't have time to implement it because we think that the probability of the failure is really low, right? And we don't have time, we don't have capacity to fix it now, so we can do it later. Just write it down. So you have this information, the next person who comes there, they can solve the problem. And revise your log, use your logs. That's really, really important so that you get used to you know how they work. Let's talk about metrics. Actually, I love metrics more than logs. And the reason is that metrics are always on the happy path. And you need to think really hard where exactly you put them. There was a quote, Alexia conference in April, and I heard that people switch off metrics, right, during the live performance. I was quite stunned, and I was thinking, what would I compare that to? And I was thinking of a plane, right? So think of a plane. We've got this, it's on the ground, and the pilot has all the metrics switched on, right? Everything is blinking, everything is showing what's happening, life is good. Then people just board the plane, they're about to fly, everything switches off, and here you go. Enjoy, right? So it sounds like really strange, doesn't it? So why did we have all the metrics on the land? Why did we need it? We didn't need that. Right? I mean, it's good to have them on the land, that's fantastic, but isn't it more important to have it in the fly, right? And the same goes with metrics. We need to have them in the live systems. We need to have them when the system actually working, when it's used. That's where our metrics are of most use. So, first rule, metrics are not just for testing, metrics for the deployment. Metrics are for the life, and they're about the performance. They're performance indicators. They show what's happening with your system, how it lives, how it breathes, what's going on there. Metrics are not free, right? They're on the happy path. And here you really need to think about your design, right? For example, if you take a timestamp, how long is it going to take, right? So, for example, monotonic time, it takes about 25 microseconds. Do you know what you measure? Do you measure something that takes nanoseconds, right? So if you get your metric, your timestamp 25 microseconds, then you measure something something like in nanoseconds, 100 nanoseconds, and then again, 25 microseconds. Well, you slowed down your system quite significantly now. So you need to understand, take measurements on your system, understand how it works, especially the tools, right? So if you use a tool, how do they do that? Where do they do the timestamp? Do they take it out of your system, or do it during the process's lifetime? Collect what you need, right? There is a temptation, you know, when we design metrics, we think, I'll put metrics here, and I'll put there, and everywhere, and I will see what's happening. When you design your system, start small, right? Only with the basics. Start with 10, 20 metrics. Don't introduce more. Get a feeling of what's happening, and then add those information. And of course, keep your metrics clean. When we talk about the types of metrics, we usually hear business metrics and system metrics, right? But essentially, you have as many types of metrics as many stakeholders you've got, right? So you've got, I don't know, tech lead, you've got developers, you've got project manager, you've got sales, you've got business analysts and things like that. They all have their own interests. And if you have those people involved and interested in the work of this particular project, that's the types of the metrics you're going to have. So let's talk about the business ones. So the business metrics, they're on the top level, and they're about business processes, right? And the reason I'm starting with the business one, because it's actually usually the ones you're going to introduce first. The reason is that these are the metrics that are interested to the people, as Francesca says, to the budget holders, right? To the people who will tell you whether you can add metrics or not. And so it's a really good idea to sort of add metrics that they will like, they will be interested. So, and these are metrics to of interest to business management, marketing, sales, and here we are talking about comparative analysis. So, for example, how your system behaved a year ago and how it behaves now. Were there any improvements? Especially maybe, you know, number of users, number of paid users and things like that, load of traffic and so on, whatever, depending on your application. Also, some kind of compliances, right? So maybe you're not allowed certain users to access. Maybe you need to provide certain level of traffic. You know, all these metrics you can incorporate them. Product metrics are a little bit closer to our code, and that's all about the product that lead to better product decision and how the users interact with your product. And here, when we talk about it, like the two important indicators, I would say, that you would usually hear when you talk about product metrics are leading and lagging. Lagging is long-time planning, and leading is the ones that are really short, and they will be just during some sprint. So these are quite useful sort of to know. They drive daily tactics, their hypothesis quickly, you check whether it works or not. So that's the two. System metrics, and these are the ones that developers are interested in, right? So that's monitoring resources, so CPU, queues, number of messages, all that information that is of interest to us. So when we talk about that, it's better to sort of consider whether you cover all sorts of metrics on different levels. So for example, host-based metrics, so CPU, memory, disk space. And actually, if you used Prometheus, these kind of metrics are already incorporated. So the only thing that you need to do is just to connect to Prometheus, and you will see that all those metrics are there. So they're sort of, you even don't need to add them. They're already there. Then application, these are the ones that you will add for you to see what's happening, how long messages again spent in the queues, how many sort of requests are sent, how long it takes to process messages request in certain level. We have network connectivity, so monitoring how good our nodes within our system are connected, and then of course its external dependencies. We send requests to third parties. How long does it take? Is there in business interest actually take that functionality and bring it into our system? Right, so all those metrics. Maybe we need to change the third-party APIs. Do I create quite a lot of headache for us? These are the things to continue. So let's have a look at the some of the rules when you work with metrics. So the first one is ensuring that the team is on board. You as the developers on board and the management is on board. So the management show them the metrics, right? Develop a couple for them. We had quite a number of cases when management wouldn't want any metrics, but as soon as they see them, it sort of brings them closer to the system. They start understanding it. They don't feel about the system as a black box anymore. It becomes like a living creature for them. So what happens is that they ask for more than. So, and that gives you a green light, right? If you add metrics for them, you can add metrics for yourself as well. So you've got sort of that covered. For yourself, well, we have deadlines and everything, but here I think it's really important to decide for yourself. What kind of a developer are you? Are you enjoying working on the weekends? Maybe you are, right? Maybe that's your escape time when you actually love the adrenaline of rushing and rescuing, and it's all really amazing, and you don't like planning. So then just accept it and say, yes, that's me. I don't love metrics because I love this style, and that's also fine. I don't share that, but yeah. The second thing is design your metrics, right? Design them from the very beginning. So when you just start with your system, make sure that the design is also there. Start with very few metrics and then just evolve them. If you already have a mature system, again with logs, don't throw many metrics there. Design doesn't mean that you design every little bit there. Design means that your approach works for your system, right? That's what a design is. So start with a few, start with 10, start with 20, see how they work. Is there a slowdown? Is there a significant slowdown, right? Is it within like the margin that you can afford, like 5%, 2%? Is it more? Do you need a redesign? So check how they work. Use the spiral approach, right? So the first round, see how it works. The second one, better, and so on. Don't add all of them in the beginning. And then make sure why you want the metrics, right? So what do you want from them? Do you want to see how your system performs? Then plan your metrics so you can see the performance of the whole system. Do you want scalability? Then start with the big things, right? Find out where the bottlenecks might be, where the your system spends lots of time, and then start sort of digging into that. You solved the problem, remove those metrics, right? You don't need too much. Again, metrics slow down your system, right? So put enough, don't put too much. Vendor locking and plan for change. So again, if you put your tools inside of your application, that's vendor locking. It will be very hard to take them out, especially if your system grows. There will be very much tolerance and kindness when you start requesting to change a tool, right? Because if something goes wrong, then that's it. Lots of time wasted, lots of money wasted. Nobody wants that. So plan for that. Have this API when your system calls an API and API calls the tools. You focus them in one module, you focus them in one application, then when you need to change that, you can quickly work in one application. That's much easier to get permission for. And plan for change, right? Your system changes, your metrics will need to change as well. And think about it, right? Be ready for that. When you design something, don't think like, it's the same that with your application, right? You design an application, it grows, you are ready for it to change. You are not thinking that that's frozen now, and that will stay forever. The same is metrics. Metrics live with your system. They also need to adapt, they need to change, to remain useful, of course. Make an effort to understand your system. That's the next rule. So you will see the metrics, you will see all the graphs, but they won't tell you anything. There won't be like a sentence above each graph telling you what exactly you need to do. You need to put an effort to understand what's happening. And here comes the less the better, right? The less metrics you have, sort of to constantly focus on, by less, I don't mean that you need to have 5, right? Have 20, have 100, make sure that they're organized, but make sure that you look at them periodically. And by periodically, I mean once a day at least. So to understand what's happening there in your system, not like once a year to sort of see that there were hundreds of crashes over the time. Your system slows down, right? Revise it, redesign it. So this approach that worked for you when you had 2,000 clients doesn't work for you anymore when you have 100,000 clients, right? So just change that, change the design, make sure that you take out some of the sort of things. You need to think what resources you've got, right? So the majority of the time, we're short for time. We need to squeeze that. So it means that if we're short for time, we need to have some memory, right, available, or make sure that we have enough memory so that we can spawn the process. We spawn the process, over some time it doesn't work for that, it doesn't work for us anymore. Spawn pool of processes, so now that you send them to a pool of processes. So think about the design, think how you change it and plan for that. Another really good sort of tip is having a hypothesis. So before you actually look at your metrics, think what you expect. And then it will help you to understand where the metrics show you a good picture or a bad picture, right? Is it that what you expected, or is it something that you don't want? Yes, and regularly look at your metrics, make sure that you keep understanding your system. Tidiness is always very good, and in particularly when we talk about metrics. The code should remain clean. The documentation, here we need a separate documentation. So for example, when with logs, we could get away from having our logs inside of our code and just reuse it. With metrics, we really need to take it outside and make sure that we look after that. A good thing is that when the design is in place, you can give it to a junior to look for that. But when I'm saying the junior, it doesn't mean that now give a junior green flag to run away and add as many metrics and whichever metrics they want. No, they need to be controlled. By junior, I mean that you give them the metrics, you tell them what needs to be sort of added or removed or whatever, and then they just keep the code clean when they add or remove. It's not difficult at all. Actually, I have a discussion with colleagues at Erlang Solutions, like whether metrics are difficult or simple. So when you have a good design in place, it's so simple, anybody can do that. But to place a good design, that's where you need to understand your system. You need to think about it. And yeah, better not to give it to juniors. Not because I don't love juniors. I've been a junior myself. But it's more about experience, right? We need experience in the design. We need those burns that hurt us, and scratches that won't allow us to make those sort of decisions when we were younger. Tools. So there are quite a number of tools. So when we talk about telemetry, telemetry is just a wrapper, right? Telemetry is to standardize things. In the Elixir, there are more telemetry-related functions that allow you actually to connect Prometheus. But essentially, for Erlang world, telemetry is just a wrapper. Then we have metric collection tools, and this can be Prometheus or Wombat. Wombat has a lot of things. It's developed by Erlang Solution. Lots of wisdom of the company, and Francesca in particularly goes in the tool. So if you're interested to hear about it, how it works and everything, speak to the stand, to the guys they're there. And then metrics display, right? That's Grafana, or any other tool. These are just examples, so just what you should expect there. So we have counters, gauges, histogram. This is essentially what we need to put our system in place. So I'll go to alarms now because there is very little time left. But essentially alarms, we put them, get from either from logs or from metrics, right? Or from both. And there are lots of things that you can extract and use, how you use them, and it all depends on the tools you use. Some of the sort of rules that I would suggest is a sweet spot. And when we ask, how do we get that sweet spot, that's practice, right? Don't put too low. You will get alarms to all the time raised on, and then you will get used to them, and they will just, that's the worst thing that may happen to you is getting used to alarms, right? Never get used to them. Too high, well, it's too late, right? The only thing they will tell you, well, the system crashed, but you can see it yourself, right? What's the point? So just practice, see where you put the alarms. Staged, right? Think about having, like, if you think about memory, right? Think like having like 60% usage memory, right? The first warning, second warning, and the third one, so that you are sort of warned, but keep an eye on them. And make sure that they get through. So the last thing you want is that your alarm stuck somewhere at the back of the queue. So we can have priorities, we can separate channels, but make sure that they're accessible. If I would like you to take away or remember a couple of things from this talk, this is about the design. Design is the key. You want your metrics to perform, you want to be happy with your metrics, design your system. And then if it doesn't work, then most likely, like 95% of the cases, the design is wrong. So just redesign it, and the life will be beautiful. You will sleep at night, you will work during the work hours, and just ask Francesca, he will confirm that. So thank you very much.
Thank you. You've talked a lot about logs and metrics, but many of us are building distributed systems and are looking at traces instead.
Yes.
Anything you can say about that?
So tracing, yes, it's observability, and we actually did a training with Francesca on that. So tracing, it's a really important thing, but it's a debugging thing, right? So it's a little bit different. So you put them when you need to sort of figure out the problem. So you wouldn't switch on when everything is running fine, unless you just want to investigate something for yourself. So, yeah.
Yeah, but when something happens, it's too late to turn tracing on.
Well, you sort of know that the bug is happening, right? So, and actually, Francesca has quite a lot of stories, so go talk to him when he actually caught the things, not with logs, not with metrics, but with tracing. Like, combination, but tracing was one of them. So yeah, it's a useful tool for sure. Yeah, but it just comes from a little bit different angle.
Do you have any guidance or thoughts about structured logging?
Structured logging? Well, that's what exactly do you, because I have an idea what exactly you mean by structured logging. just to make sure that we're on the same page.
Right, where the logs are not just strings, but actually like JSON payloads or something that can be used as data as well.
That's excellent. Yes, I'm very positive about them. Yes, if they're structured, you can sort of put information into that. So that structured, it's good in the way that you have like a schema or something, and from that schema you sort of fill that information, and you're making sure that this information is everywhere. So it's an excellent practice, and yeah, it's really good to have them.
Thank you. About logs, you mentioned the use of IDs so that you can more easily find where they come from. Is there a difference with just putting the file and the line that the log is coming from?
It's more information, isn't it? Like file and the name. Probably it's the same. Yeah, I think the sort of from information point of view, it's the same thing. But you, for example, file, you have line number, whereas the code can be just very short, like 5 characters or something like that. So I think it's the same, but just a little bit shorter, and it's just easier. And another thing, you may change the file, right? The file name for some reason, right? Whereas the code will probably stay the same, so it means that less places where to change things, right? So.
Okay, thank you for the questions. Let's thank again to our speaker.
Thank you.